Hey guys, Mr. Milton here. Today we're looking at adding and subtracting radicals notes. At the end of this video, you should be able to add and subtract radical expressions. All right, it says use the properties of exponents to simplify each. So we have 2x cubed times 4x cubed. We did this a couple chapters ago. 2 times 2 is 8. X cubed times x cubed. Remember that we added those exponents when we're multiplying. Gives us 8x to the 6th. Number 2, x to the 5th times 3x squared. Okay, so 1 times 3 is 3. X to the 5th times x to the 2nd, x to the 5 plus 2, 7. Number 3, we have 2x cubed plus 4x cubed. Remember when we're adding and subtracting polynomials, we need to have like terms, and we do have them. And so since we do have them, we have 2x cubes and 4x cubes, meaning we have 6x cubes. Okay. Number 4 says add x to the 5th plus 3x squared. Again, we need to have like terms to do addition and subtraction. And here we don't have like terms. These are not like terms. And so we just write our answer in standard form, simplified as possible, which is like this. Okay. Remember, when multiplying, we can multiply unlike terms. Multiplying, just multiply. And that means different variables and exponents. I guess different variables. And the exponents will change in your answer. Okay, when adding or subtracting, we can't add or subtract unlike terms, and the exponents will not change in the answer. You simply add or subtract the coefficients. And remember, that's just the numbers in front of the variables. Okay, and if our variables are not the same, you can't do it. Okay, how does this apply to radicals? Well, it's kind of the same thing. So when we're multiplying, we don't need to have like terms. 3 radical 6 times 2 radical 5. Remember, our rule was outside times outside. 3 times 2 gives us 6. And inside times inside. Radical 6 times radical 5 gives us radical 30. Now, anytime we're simplifying or multiplying radicals, we do want to check to make sure our radical is as simplified as possible. Hopefully, we've been dealing with radicals long enough. We know radical 30 doesn't simplify any further. It'd be like 6 or 5 times 3 times 2, so no groups, no pairs. All right, what if we were adding these two? 3 radical 6 plus 2 radical 5. If we were going to simplify that, we just have it as 3 radical 6 plus 2 radical 5. Okay, they're not the same. Okay. 7 radical 3 plus 4 radical 3. In this case, they're both radical 3s. When we're adding and subtracting, we have to have like terms. We do have like terms. This will give us 11 radical 3. Our numbers on the outside change because we're adding them, but our numbers on the inside doesn't. Okay, this problem would be very similar to us saying 7x plus 4x, right? Or our top problem would probably be more similar to 3y plus 2z. We wouldn't be able to add those together because they're not like terms. Okay, so when multiplying, we can multiply on like terms, just like with our variables. That's different radicals in this case. And the numbers under the radical can change in your answer, or will change in your answer. Okay, when adding or subtracting, we can't add or subtract unlike terms, and the numbers under the radicals will not change in our answer. I said will change, sorry. I'll write that there so we can have it. Okay, we simply add or subtract the coefficient. Okay, so pretty basic rules, really the same as we dealt with variables and polynomials. Just have to make sure that we understand how that transition or that change looks when we're dealing with radicals. So here it says find the sum or difference of each radical expression. As we look, we're going to identify like terms, put them together because it's addition. So 4 radical 7 plus 5 radical 7 gives us 9 radical 7. We have 7 radical 2. It doesn't have any like terms with it, but so we just keep it that way. Okay. Number 2, we have 5 radical 6 minus radical 6. Now, here's a common mistake. So this is not right. Here's a common mistake. People will say, oh, radical 6 minus radical 6, the answer is 5. No. Okay, remember, they have to be like terms, and like terms will stay like terms. Be like if I said I had 5 apples minus an apple, what do I have? You wouldn't say 5. Okay, it would be still number of apples. Okay, I have 5 radical 6s minus 1 radical 6. 5 minus 1, 4. And they're still radical 6s. Okay, so seems pretty simple. What's the catch? Let's run into some more complicated things here. So it says simplify 3 radical 5 plus radical 80. As we look at this problem initially, you're like, hey, these are different radicals. They're unlike. They're unlike terms. So you can't combine them. However, here's the difference between variables and radicals. Radical 80 can be simplified further, which we must do before we say we're done. So, as we simplify radical 80, looking at pairs of numbers, I'm going to look and say, hey, 16 times 5, 4 and 4. So we have a pair of 4s that goes on the outside, and a 5 that doesn't have a pair, so it stays inside of our radical. Now we have like radicals. These are like terms now. So we have 3 radical 5 plus 4 radical 5. So our simplified answer now is 7 radical 5. And here's the difference between radicals and variables. An x is never going to turn into a y. It's just not going to happen. But radical 80 could turn into a radical 5. Okay, and that's what you have to make sure that you're looking for in each of these problems as you're adding and subtracting and looking for your final answer. Okay, so number 1, we have radical 27 minus radical 12. Okay, again, at the beginning, not like terms, we're going to simplify this. 9 and 3, 3 and 3, so this becomes 3 radical 3. Radical 12, 2 and 6, 3 and 2, have a pair of 2s and a 3, so 2 radical 3. So we have 3 radical 3 minus 2 radical 3. Our answer then, 3 minus 2 is 1 radical 3. So you can either write it as radical 3 or 1 radical 3. Either way, it's fine. Number 2, we have radical 25 plus radical 64. So we simplify 25 ways, that's a perfect square, that's 5. Radical 64, that's a perfect square, that's 8. Oh, we can't add these together because they're not like terms. No, I'm just playing. Okay, 5 and 8 are just numbers. We already know we can add those, right? 5 plus 8 is 13. Number 3, we have radical 18 plus radical 36. So I'm going to simplify radical 18. What is that, 9 and 2? That breaks down to 3 and 3. So we have 3 radical 2 here. And then radical 36 is 6 and 6. Oh, we have a pair. Okay, we could break it down further, but I already see a pair. So 3 radical 2 plus 6. Or 6 plus 3 radical 2, however you do that. Okay, and so here are just a few examples of us simplifying our radicals so that we can add and simplify our terms. Let's look at a few more challenging problems here. So we have 6 radical 27 plus 2 radical 75. Here, the rules and concepts stay the same, but now we're just dealing with either bigger numbers, numbers on the outside, things we have to remember as we evaluate our problem. Okay, so 6 radical 27, I'm breaking this down. This is 9 and 3, 3 and 3. So 6 times 3 radical 3, 6 radical 27 simplifies to 18, 6 times 3, radical 3. 2 radical 75, that's 25 times 3, it's 5 and 5. So that gives us 2 times 5 radical 3, or 10 radical 3. So 18 radical 3 plus 10 radical 3s. How many radical 3s do we have? They're like terms, so we can add them. 28 radical 3. Remember, when we add or subtract, our radicals don't change. If they're like terms, they stay what they are. Number 5, we have 3 radical 200. So as I look at that, I see 100 in there, times 2, 10 and 10. So I have 3 times 10 radical 2, which gives me 30 radical 2 here. We have 6 radical 50. So that's 25 times 2. That's 5 radical 2. So I have 6 times 5 radical 2. Gives me 30 radical 2. Huh? So 3 radical 200 is the same as 6 radical 50. That's crazy. Okay, subtracting. That gives me 0. I could say 0 radical 2, but like 0 times anything is just 0. So there's my answer. All right, number 6, we have 2 radical 54 plus radical 108. So 54, that's 9 times 6. 3 and 3. 3 and 2. So I have a pair of 3's. And 3 times 2, no pairs, so I'll multiply those. And then there's a 2 already on the outside, so I'm going to have that out there. 2 times 3 is 6. So 2 radical 54 simplifies to 6 radical 6. Okay, radical 108, that gives me 9 times, what is that, 12? Yeah. All right, 3 and 3, so I have a pair of 3's here. 4 times 3, 2 and 2, pair of 2's. Okay, so pair of 3's, 3 on the outside, pair of 2's, 2 on the outside, and then 3 without a pair. So this becomes 6 radical 3. So 6 radical 6 plus 6 radical 3, I can't add those together. They're not like terms, right? They both have 6's, but inside of our radicals, where we decide if they're like terms or not, and we have radical 6 and radical 3, different. So as simplified as I can make it, 6 radical 3 plus 6 radical 6, or 6 radical 6 plus 6 radical 3, either way. Works out. All right. Last one here, we have radical 40 minus 2 radical 90. So that gives me 4 times 10. 5 and 2. 2 and 2. So I have a pair of 2's. Goes on the outside. 5 and 2, no pairs. So multiply it together, we get radical 10. So 2 radical 10 there. On the other side, I have 2 radical 90. So that's 10 times 9. 5 and 2. 3 and 3. So I have a pair of 3's that goes on the outside. 2 times 3 radical 10, so 6 radical 10. So 2 radical 10 minus 6 radical 10 gives us negative 4 radical 10. Okay, they're like terms, so we can do that. It's a negative here with the radical, which might make you think twice, but the negative is outside of our radical, and so that's okay. And negative 4 radical 10. All right, so there we have it, adding and subtracting radicals. Making sure that we are simplifying our final answer, and that should be it. See ya.